this video class, we will discuss about the numerical problems related to molarity. Okay, and actually this is your assignment 7A. Okay, so the first question is here it is written that suppose we have a 250 ml of 3 molar sodium hydroxide solution in a beaker. So that means we have a beaker, okay, and in that beaker we have 3 molar sodium hydroxide solutions. And how much of this solution is present? Actually we have total 250 ml of that given solution. Okay, so here it is again given that let's suppose you forget to cover the beaker properly. Okay, so if we forget to cover the beaker, then what is going to happen? Because of the temperature of this room, the water molecules will going to evaporate slowly. Okay, and after a few days it says that 10% solvent molecules are evaporated from the beaker. Okay, then what we have to find out? We have to find out the number of sodium ions present in the given solution. If only water molecule can evaporate from the beaker, that means the solute will not going to evaporate. So, okay, that means the number of sodium ions which are formed because of the dissociation of sodium hydroxides will going to be same as initial condition. That means if we add 3 moles of sodium hydroxide, then after the evaporation of water, 3 mole of sodium hydroxide will be remain there. Okay, so here what do you mean by 3 molar sodium hydroxides? We know that 1 molar any 1 molar solutions means what? 1 molar solution means in that solution, okay, 1 mole of solute will be dissolved, and the volume of that solution should be what? 1 liter. That means what? That means 1 molar solution means in 1 liter of any solutions, 1 mole of the solutes are dissolved. But here it is given that 3 molar sodium hydroxides are there. Okay, that means what? That means 3 mole of sodium hydroxide will be present in 1 liter. Okay, so 3 mole of sodium hydroxide will be present in 1 liter. Okay, understand? But here again here it is given that we have only 250 ml, not 1 liter or not 1000 ml. Okay, that means we have to divide by 4 to get the number of moles of sodium hydroxide which are dissolved. That means here we can also write like this actually, in 1000 ml, okay, solution, total 3 mole of sodium hydroxide is present. Understand? Because 3 mole of sodium hydroxide means what? 3 mole of sodium hydroxide means in 1000 ml solution, total 3 moles of sodium hydroxide will be dissolved. Understand? And in 250 ml of solutions, how much sodium hydroxide will be dissolved? 3 by what? 3 by 1000 into 250 moles of sodium hydroxide will be dissolved. So that means this amount of sodium hydroxide will be dissolved in that solution. So after dissolving that amount of sodium hydroxide, they will going to form what? Sodium hydroxide will going to form sodium positive and OH negative ions, and we know that 1 mole of sodium hydroxide will going to form 1 mole of sodium positive and 1 mole of OH negative. Clear? That means if we have 3 by 1000 into 250 moles of sodium hydroxides in that solution, that means we have also 3 by 1000 into 250 moles of sodium positive. Understand? So up to this I think you understand. So now we have the number of moles of sodium ions which are present in that solution. Okay, again they said that water will going to evaporate, but they here not mentioned that the sodium positive ion will not going to actually evaporate because solids are remain same. Solids will not going to evaporate. So that means after evaporation of that 1% solvent, also the the number of moles of sodium positive will be what? Sodium positive ion will be also 3/1000 into 250 moles. Understand? So now we have the number of moles of sodium positive ions, and from this number of moles of sodium positive ions we can get the number of ions, that means number of sodium positive ions. See, because we already know that 1 mole is equal to 6.023 into 10 to the power 23 number of that particular species. Okay, so that means here ions are present, sodium positive ions, and this is in moles, so we can convert this mole into number of that ions, okay, by multiplying what? 6.023 into 10 to the power 23. Understand? So that means we have total how much? Total 3/4, that means 3/1000 into 250 into 6.023 into 10 to the power 23 number of what? Number of sodium positive ions. That means we can just multiply with the Avogadro number to get the number of sodium positive ions. I think you understand. Okay, so the value will be what? 4.517 into 10 to the power 23. That means the option C is the correct option. Hope you understand this question. And to solve this type of question, actually you have to clear the concept of the molarity as well as moles. Understand? So now coming back to the question number 2, which is actually the same question, but here the difference is that we have to find out the concentration of the resultant solution after removal of 10% solvent. Okay, so initially we have 250 ml 3 molar sodium hydroxide solution. Okay, so after removal of 10% solvent, how much solution we have? Actually, how much the solution we have? So you see here 10% solvents are evaporated. That means if 100 ml solution we have, then from the 100 ml solution 10 ml solution will be evaporated. Okay, so in case of 250 ml solution, we're going to actually lost total 10 divided by 100 into 250 ml solution. Okay, that means 25 ml solvent will be lost from that solution. Okay, so that means the final volume of the resultant solution will be what? 250 minus 25, that means 225 ml. Okay, so now we can use a relation which is actually known as M1 V1 equal to M2 V2 to solve this equation. Okay, so let's suppose the M1 represent the initial volume of that, M1 represent the initial concentration of that solution in molar, and V1 represent the initial volume of the the solution, and suppose M2 represent the final concentration of the solution after removal of 1% of that solvent, and P2 represent the final volume of the solution after removal of the 1% of the solvent. Okay, so then we can just put the value here. You see what we have to find out? We have to actually find out M2, because we have to find out what? The concentration of the solution after removal of the 1% solvent. Okay, so here in place of M1 we can put 3M. Okay, and in place of V1 we can put 250, and in place of V2 we can put 225. And if you just cross multiply and just using the simple mathematical technique or mathematics, we can have the value as 3.33 molar. Okay, so that means the concentration of the resultant solution will be 3.33 molar. So that means the concentration is increasing. You see, initially it was 3 molar and it will become now 3.33 molar after removal of 1% solvent. Yes, it is evident. You see, when the solvent is actually evaporated from that solution, then the concentration of that solution will become more, because the solvent will going to decrease. Understand? It's very simple. So the option B, that means 3.3 molar, is the correct option. Okay, understand? So now coming to the question number 3, which is, what do you mean by 5 molar solution of HCl? Okay, so what do you mean by actually the 5 molar solution? So here some options are given, so we have to find out the correct options. Okay, so what do you mean by actually 5 molar solution of HCl? So we know that 5 molar HCl solution means in that solution total 5 moles of solutes will be present. That means 5 mole of HCl will be present or dissolved. Understand? So that means here if you look at the first option, you see in 2 liter of 5 molar HCl solution total 365 gram of HCl molecules are dissolved. So we know that 5 molar means 5 moles of HCl. Okay, so here it is written 2 liter of 5 molar. That means here total 10 moles of HCl will be dissolved, because 2 liter in 1 liter 5 moles, so 2 liter 10 moles. So we have the moles now, and we know that 1 mole is equal to how much gram? Actually 1 mole is represent the actually gram molecular mass. Now 1 mole is equal to how much? Actually 1 mole HCl is equal to how much? Actually what is the weight of, or what is the mass of 1 mole HCl? We know that the molecular mass of HCl, that means 1 mole HCl will have mass what? 36.5. If you calculate the molecular mass of HCl, then it will be 36.5, because atomic mass of hydrogen is equal to 1, chlorine is equal to what? 35.5. If you add up both of them, then it will become 36.5 gram. Okay, so it is 36.5 gram for how many? For 1 molar. But for 5 molar it will be what? 5 into 36.5. But here how much liter is present? 2 liter. So we have to again multiply with 2. That means 10 into 36.5 gram. That means 365 gram. That means in that solution, in 2 liter of 5 molar HCl solution, total 365 gram of HCl molecules are dissolved. So this option is the correct option. Understand? So what is the second option? Water is used as solute. So water is not solute here, because water amount is actually more than the the HCl. So water will going to act as a solvent here. So it is wrong. And what about the third option? Third option is what? 5 moles of HCl are dissolved in water to prepare 2 liter solution of given concentration. No, this is also wrong, because we know if we add 5 moles of HCl in 1 liter, then the the concentration will be your 5 molar. Okay, but here actually it will be your 2.5 molar solution, because it is 2 liter, because it will become, the concentration become half of the 5 molar. So this is also the wrong. Okay, so what about the last option? Last option is, so 5 moles of HCl are dissolved in 1 liter water to prepare 5 molar HCl solution. So this is actually the tricky option. Okay, so you have to write properly. So this is actually wrong. Why wrong, you see? So here it is written that 5 moles of HCl are dissolved in 1 liter water. So if you add the 5 moles of HCl, so actually the 5 moles of HCl has also some volume. Understand? It also have some volume, and if you add that volume with 1 liter of water, then the final volume of the solution will be more than 1 liter. But we know that to prepare 5 molar HCl solution, we have to add 5 moles of HCl with water to make the final volume of the solution to 1 liter. So if we add 1 liter water with that volume of the 5 moles of HCl, then the actually we will not going to get the 5 molar HCl solution. Understand? So this option is also the wrong option. So that's why you have to read the actually every options very carefully, and also you have to clear your concept, okay, properly, otherwise you will going to miss the correct answer. Understands? So this is the tricky question. So that means in actually the which one is your correct answer? The option 1, that means A, which is in 2 liter of the 5 molar HCl solution, total 365 gram of HCl molecules are dissolved. Understand? So now coming to the question number 4, which is if the density of concentrated sulfuric acid is 1.8 gram per liter, 98%, that means it is not totally pure, okay, so 98% pure, then how much ml of concentrated sulfuric acid are required to prepare 1 liter 0.1 molar dilute sulfuric acid solution, given that the molar mass of the sulfuric acid is this amount, okay. So now what we have to find? We have to find out actually how much concentrated sulfuric acid is required, okay, to prepare 1 liter 0.1 molar solution, okay. So here we have to use the actually the relation or actually relation or the expression of molarity. Actually molarity is equal to define as what? Molarity M is equal to actually gram per liter divided by molar mass, okay. So here we know the molar mass of the sulfuric acid, which is 98.079 gram per mole, and we know the molarity of the dilute sulfuric acid which we have to prepare. So how much we have to prepare? 0.01. So here we can write 0.01 molar, and here the actually molar mass of the acid, okay. So but here we don't know the gram per liter, so that means we can calculate the gram per liter. That means we can calculate how much amount of sulfuric acid is required to prepare 1 liter of the 0.1 molar dilute sulfuric acid by getting the gram per liter, okay. So just do the cross multiplication and we'll get the gram per liter, which is equal to actually 98.079 gram per mole into 0.1 molar, okay. So it will be actually 9.8079 gram per liter. So what is the meaning of it? The meaning of it is that to prepare 1 liter of 0.1 molar dilute sulfuric acid, we need how much concentrated sulfuric acid? We need 9.8079 gram of concentrated sulfuric acid. But here we have to find out how much ml of that concentrated sulfuric acid is required. That means how much volume, okay. So we can convert this gram or this mass into volume by using the density formula, which is density is equal to mass per volume. So volume of that amount will be actually V is equal to the mass bar density. So the mass is equal to 9.8079 gram divided by density is equal to what? 1.83 gram per liter. But density here, it actually the the solution, the concentrated solution is not 100% pure, it is 98% pure. So we have to multiply or we have to divide this this mass by 0.98 to get the volume, okay. So if you calculate this this mathematical problem by using a calculator, then you will get the value as 5.47 ml. So that means the option C is the correct option. I think you understand this problem. This is not so hard problem, it is an easy problem. So actually I have already give this type of example or this type of numerical numerical problems in the previous video class, which is actually part 4B solution chapter, okay. Unit 2 part 4B. You can go through that in a video also if you don't go through it. But in that video we have discussed about the normality, okay, but here molarity. So in that case the difference is that in place of molar mass, here we use molar mass, but in normality case we used that equivalent mass, okay. So hope you understand this question number 4. So now coming to the question number 5, which is the last question of this assignment 7A, which is from the value of concentration in molarity of a solution we can know the, so that means we have find out the correct options from this 5 options. Okay, so the first option is that if we know the molarity, then we can have the value of the number of moles of solutes dissolved in the solution if we only know the molecular mass of the solutes. No, I think this is not correct, incorrect, because I think we already know molarity is equal to, and molarity is equal to gram per liter by molar mass. Okay, so here in this option it is given that if we know the molarity, okay, and if we know the molar mass of the the solutes, and then we can calculate the number of moles of solutes dissolved in the solution. No, it is not correct, because if we only know the molarity and the molar mass, then we cannot calculate the gram G. Okay, this G represents the actually the number of moles of actually weight of or mass of the solute, okay, which is dissolved in the solution. And from the mass of the solution solute, you can actually calculate the number of moles of the solutes, but only when we know the L, that means the volume of the solution. So that means to know the number of moles of solutes, we need to know about the volume as well as the molar mass as well as the molarity. So one thing is actually missing here, so it is not right. This is the incorrect option. So what about the second option? So the second option is actually if we know the molarity of the solution, then we can know the molecular mass of the solute if we only know the number of moles of the solute dissolved in the solution. No, this is not correct, because here also volume is missing. Okay, so what about the third option? The third option, according to third option, actually if we know the molarity of the solution, then we can calculate the number of ions present in the solution if we have the molecular mass of the solute and the volume of the solution. Okay, this is correct, because you see, if we have the molarity, volume and molar mass, then we can calculate G, that means the amount of the solute which are dissolved in that solution. Okay, that means this G, okay, this G can be calculated. So if we calculated this G, then we can calculate the number of moles of that solutes which are dissolved in that solution also, because this G by this molar mass is equal to number of moles of that solute which are dissolved in that solution. Okay, so once we have the number of moles of that solute which are dissolved in that solution, we can calculate the number of ions which are present in that solution also, because we know that that solute will going to dissociate into their ions, and if the if the solute, 1 mole of solute will going to give 1 mole of positive ion and 1 mole of negative ions, then we can calculate the number of actually moles of ions, okay, from that number of moles of the solutes. Okay, so if the number of actually if 1 mole of solute will going to give 1 mole of that ions, then actually the number of actually moles of ions will be equal to the number of moles of what, your solutes. That means number of moles of positive ion equal to number of actually moles of your solute. Okay, understand? So by multiplying this number of mole into 6.023 into 10 power 23, we can get the number of actually ions. Okay, so this option 3 is the correct option. Okay, so what about the fourth option? None of the above option is correct, so this is incorrect option. What is the last option? The first 3 options are correct. No, this is also not correct. So that means the option C is the correct option. Hope you understand all the questions. Okay, so I think you now understand that you have to clear your concept, okay, properly to solve some tricky and conceptual questions like this 5. Okay, and these 5 questions are not so easy questions. Okay, they are very conceptual and tricky. Okay, so actually I just want to check how actually deep you can think, or how deep actually you are studying your topics. Okay, so actually you can solve the other problems or other NCERT board problem or numerical problems by just studying the NCERT book, but to solve some conceptual and tricky questions like this, you have to clear your concept properly. Okay, so hope you understand the importance of clearing the concept properly, and in the next class we will continue the next part of the solution chapter. Okay, thank you.